Let us discuss the concept of shift of an object due to multiple slabs. Here in this picture you can see there is an observer who is looking along the near normal incidence line to an object through three transparent slabs of thicknesses T1, T2, T3 and refractive indices mu1, mu2 and mu3. Now if we wish to find out by what distance the object will be shifted nearer to the observer, we analyze the situation by assuming a negligible air gap between the interfaces of the three slabs. If the medium on both sides of slabs is air, we can split the situation again into three slabs of same thicknesses, but there is some gap between these slabs. We assume the thicknesses are T3, T2 and T1 with refractive indices mu1, mu2 and mu3, and we consider the object at the same position. Here we can just analyze the image formation by using a light ray which will incident onto the slab. This is slightly displaced and emerging out at the same angle of incidence. So this ray will be finally parallel to the initial ray. If this is the initial ray, the light ray which is coming out in air, we are assuming negligible air gap, because this negligible air gap does not create any difference in image formation, because the shift due to negligible gap is almost negligible. Now in this situation the light appear to be coming from this point, and this will be the shift of object S1 which is due to the first slab. And again for the second slab the light will get in and finally emerge out at the same direction. Here this direction is again parallel to the initial direction. This will also be same, and this is the distance by which this first image is shifted, which is say S2. And finally the light is coming out from the third slab in the direction in which the original ray was incident onto the slabs. Here the figure drawn may not be appropriate, but you can understand the concept that in all these air gaps, the light ray which is coming is parallel to the initial ray, and the same thing happens for all the rays which are originated from object. So the final light is also, this appear to be coming from this point, which is the final position of image where object will be seen by this observer. Because this is the final refracted ray which is getting into the observer's eye, and this ray and the ray which is passing along the normal will be used to produce the final image. So here we can find out the total shift of object by all the slabs will be equals to S1 plus S2 plus S3, and this can be written as T1 1 minus 1 by mu1 plus T2 1 minus 1 by mu2 plus T3 1 minus 1 by mu3, and even if more slabs are there, total shift can be added, which is due to total shift can be given by the addition of all the individual shifts produced by the independent slabs considered individually.